Hello everyone, today we'll talk about the problem number of students unable to eat lunch. Here we're given quite a convoluted story about students and cafeteria offering sandwiches. Sandwiches are of two types, 0 and 1, and every student has a preference in that they eat only the type of sandwich of their choice. So if their preference is 0, they cannot eat sandwiches of type 1 and vice versa. And what we have here is a cafeteria has a stack of sandwiches for students to take. So this one will go first, then this one, then this one. Students are in a queue, so here are the students. And so this one will take their sandwich and all is okay. Then this one will take their sandwich, all is okay. And now we see a student that has a different preference than this sandwich that's right here, and they go to the back of the queue. Now this guy and this sandwich, they are okay, so he's happy. Now this guy wants a sandwich of type 1, this is type 0. This guy has a preference for type 1 again, this is type 0, and now they cannot take any more sandwiches. So two students cannot eat a sandwich. And our job is to say how many students are unable to eat their sandwiches. Now, since this is an easy problem, right, classified as LeetCode easy, the bounds are quite lenient, and it would be possible to simulate this process, right? Because, for instance, if you had a big block of students of preference 1, and then a big block of preference 0, and the cafeteria had an alternating stack of sandwiches, then that simulation might take a lot of steps. But how many steps exactly? Well, we can see that when the queue, as it stands right now, when everybody sees that, well, this is not a sandwich that they want, so they go to the back of the queue. And if that happens for every student, then we are sure that, well, none of these students can eat their sandwich. So in other words, at least one student in each full rotation of the queue has to eat their sandwich. Otherwise, this is the end state. And so we will rotate the whole queue at most as many times as there are students. So for the bounds of this problem, that would be okay. But of course, we want to find out if we can solve it in a simpler way and of course a faster way. And I think the simplest idea for a faster solution to this problem is to notice that we don't really, since we are not of course asked which students are unable to eat their sandwiches, then we don't really care about what is the exact structure of our queue, but only how many ones and how many zeros are in that queue. And more specifically, the end state would be one that there are either no students in the queue, and that's fine, everybody has got their sandwich, or there are students of only one type. And of course, if there are students of only one type in the queue, and the top sandwich on the cafeteria is the type they don't like, then they will rotate indefinitely, so they will not get a sandwich. Otherwise, if for the sandwich that is on the top of our stack, there is somebody who prefers that sandwich in our queue, then at some point they will get to be the first in the queue, they will eat that sandwich, they'll be happy, right? Or somebody else who has the same preference, but we don't care about that. So essentially what we only need to remember is how many students prefer sandwiches of type 0 and of type 1, and we know that for as long as there is a student preferring the type of sandwich that is currently on top of the stack in our queue, they will get to eat that sandwich, so we can just get rid of that sandwich and reduce the count of students who prefer that type of sandwich. Okay, so let's see the code. In this case, we will keep counts of remaining students for every type of sandwich. We go through all those students, remember their preference by increasing the count. And currently, we assume that none of them get to eat their sandwiches. And now we go through that stack and feed the sandwich to one of our remaining students for as long as it's possible. And it's not possible when there are no more students that want the sandwich that's currently on top. And in that case, we can just decrement and of course we decrement the result every time we feed the student and we return the result at the end. This of course has linear time because we just go once through all the students, once through all the sandwiches.